Dear students, we are today learning trigonometry. This is a topic for AP Ssc Maths. This is in semester 2, and you can see from your textbook trigonometry is nothing but tri means 3, gon means sides, gon or we say gonal, and metron is measurement. So try 3 gon metron, that is measurement of 3 sides. Measurement of 3 sides of a triangle is the basic purpose of trigonometry. This is actually the very purpose of trigonometry. Why you need the measurement of sides? In good olden days, suppose you want to find the distance between two astronomical objects, or you want to find the height of a hill or a tall tree. You cannot measure using a scale. It's not possible. So what we used to do is measure the distances or the heights using a separate technique, and this is trigonometric technique. So basically trigonometry is useful in or to measure heights and distances. This is the very purpose of trigonometry. How do you do it? In the advanced classes, that is higher level mathematics, these trigonometric ratios are generally taken as functions, and they are treated differently. But as of now, the trigonometric heights and distances are measured using ratios of sides of the triangle. Why do you consider ratios? Ratios are considered because only by using the principle of similar triangles, we can estimate the larger heights and distances. This you might have learnt using in the similar triangles chapter. You have, suppose this is a triangle, you draw another triangle of the same angles but drawing a parallel like this. So that is this is A, B, C, this is a D, E. The angles are equal. Since the angles are equal, these two are similar triangles, but you can use basic proportionality theorem or this. And in basic proportionality theorem or any theorem related to similar triangles, ratios are used. We are not bothered about the exact distance. This exact distance we are not bothered about. We are bothered about the ratio. And using the ratios, you can find the distances or heights. Therefore, we define ratios of the sides in a triangle. And since we measure heights and distances, right angled triangle is considered. So this is all about why we consider a right angle triangle and why we consider ratios. Now consider a right angled triangle with this is as in the textbook I am using the triangle as given in the textbook. Consider a right angle triangle like this. The right angle triangle is ABC, and here you see it is 90 degrees right angle. Right. Now let us before we consider the ratios, we define certain terms. Consider this angle A. The side opposite to this is opposite side. The side next to this, that is very near to this, adjacent side. And this side opposite to 90 degrees. This is side opposite to 90 degrees. This is hypotenuse. So now we have defined three sides. With respect to the angle considered here, suppose the angle is this will be opposite. It will be opposite like this. Suppose if I consider the angle C, the opposite will be AB, the adjacent will be BC, and the hypotenuse is same. So it depends on what angle or which angle you consider. Depending on the angle, we define 6 ratios, of which first one is the sine theta. So the first ratio is SINE, sine A, let us note theta, or SINA, sine A. Sine A is defined as a ratio of this side opposite side by hypotenuse, and the opposite you have seen. See, the opposite is you can check, it is BC. So it is BC by hypotenuse you have seen it is AC. The second ratio defined is cosine A. We write or abbreviate it as cos A, and the cos A is the ratio of adjacent. This is adjacent AB, adjacent side by hypotenuse, and the adjacent side is AB and hypotenuse is AC. Third ratio defined is tangent A. We write it as tan A, and tan A is defined as the other two sides remaining. Here opposite by hypotenuse is taken. The second is adjacent by hypotenuse. This is adjacent by hypotenuse is taken. And the third left are opposite and adjacent. Therefore, there is the third ratio is opposite side by adjacent side, and the angle is this, opposite is BC. This you can see, BC, and adjacent is AB. Therefore, BC by AB. These are three fundamental ratios that we define. And the next ratios, the other ratios we consider are simply reciprocals of this sine. The reciprocal will be cosine, cosecant. So, sine reciprocal is cosecant A. We write it as Cosec A. And this reciprocal of sine, and the sine is BC by AC, and the reciprocal will be AC by BC. Or we should write it, we should write it like hypotenuse by opposite side, hypotenuse by opposite side, and hypotenuse you can check as AC. It is AC by opposite side is BC. The next ratio is the reciprocal of cosine, and you see in the cosine the next ratio is cosine, and the reciprocal is called secant A, SECA, secant A. Naturally, it is reciprocal means hypotenuse by adjacent side, hypotenuse by adjacent side. Hypotenuse by adjacent, you can check it as AC by AB, AC by AB. And the sixth one is, of course, we can easily, this is the reciprocal of tangent. It is cotangent. So it is cotangent A, otherwise called cot A. Cot A reciprocal of tan A, it is adjacent by opposite. And the adjacent to A is AB, and the opposite is BC. So these are 6 ratios we define to find the heights and distances. At a later stage, we define sine, cos, tan, etc. as functions, not as ratios. So in intermediate, we will learn about the functions, sine function, cos function, etc. But now, as of now, they are simply ratios, right? So this is all about it. Thank you.